Hello, my name is Kenneth Cottrell. I am a doctoral candidate in public policy at the University of Nevada, Las Vegas, where my research focuses on energy efficiency, demand response, the role of digital infrastructure, and grid modernization. Today I want to unpack the difference between AI traditional data centers and Bitcoin mining operations. We explore their energy use, location strategies, and how energy management systems and demand response programs can help both types operate more efficiently and profitably. Let's start with some basics. Traditional and AI data centers support cloud services, enterprise software, large-scale machine learning models. These facilities are built for uptime and reliability. Bitcoin mining facilities, by contrast, run high-intensity calculations around the clock to earn cryptocurrency rewards. Their performance measures are purely in throughput and hash rate. That's the key difference. Uptime versus throughput is what drives everything from design and location to energy behavior and grid impact. When it comes to energy usage, AI data centers are extremely power hungry, consuming 1,500 to 3,000 kilowatts per megawatt of IT load, mostly due to GPUs and deep learning workloads. Traditional enterprise centers average around 500 to 1,500 kilowatts, depending on their power usage, effectiveness, or PUE. Bitcoin miners operate at full capacity nearly 24/7. Their flat, high-volume energy demand can exceed 10 to 100 megawatts per site. It's mostly entirely inflexible, unless financial incentives or power market signals make it worthwhile to power down. Both these types of facilities are expanding quickly, and that creates both pressure and opportunities for the grid. AI and traditional data centers are often located near fiber corridors, water resources, and urban hubs like Northern Virginia, Reno, or Columbus, Ohio, where there's access to reliable infrastructure and tech talent. In contrast, Bitcoin miners go where the power is cheap, stranded, or surplus. That means rural areas like Texas, North Dakota, parts of Canada, or even countries like Iceland and Kazakhstan. Their goal is simple: maximize uptime at the lowest possible cost per kilowatt hour. Each type of facility different challenges to the grid. AI workloads are bursty and can drive high peak demand. Bitcoin miners draw a consistent, unyielding load that stresses local transmission and distribution systems, but that also means types of operators are ideal candidates for flexible load programs if the right technology and incentives are in place. That's where energy management systems, or EMS platforms, make a difference. EMS tools allow facilities to monitor real-time energy use, forecast, and avoid demand charges, shift or curtail non-essential loads, integrate on-site renewable or batteries, and provide performance data for compliance or ESG goals. For both AI and crypto operators, EMS gives visibility and control over energy, turning it from a fixed cost into a strategic advantage. Demand response is a utility or grid operator program where companies are paid to reduce or shift their energy use during peak demand periods. There are multiple forms: time of use pricing, load containment programs, automated direct control. But the key idea is this: you get paid to be flexible. With the EMS in place, both AI data centers and crypto mines can plainly participate without sacrificing uptime or compute goals. At GreenChain Incentives, we help clients do that. We work with data centers and blockchain operations to identify eligible demand response and utility incentive programs, integrate EMS tools to the operation, develop flexible load strategies aligned with uptime requirements, and incorporate tokenized energy credits for carbon tracking and sustainability reporting. Whether you operate a hyperscale AI hub or remote Bitcoin farm, we build custom roadmaps to turn energy management into a revenue-generating asset. Let's look at a quick example. Riot Platforms, one of the largest big mining firms in Texas, earned over $30 million in 2022 from curtailing operations during grid stress in ERCOT, demand response market. They didn't mine a single Bitcoin for that payout. They simply paused operation when the grid needed relief. That's the potential we're talking about. In another case, An AI data center in Northern Virginia used the EMS to reduce a peak demand charge by 18% without affecting performance. And internationally, GreenChain is supporting EMS deployments for digital infrastructure and facilities in Latin America. So what's the takeaway? AI and Bitcoin mining data centers are here to stay, and they're growing fast. But they don't have to be a threat to grid stability or sustainability. With the right tool, EMS platform, demand response participation, and strategic consulting, they can be part of the solution. Thank you. Have a wonderful day.